Good morning, one and all. My name is V. Abjit Kumar. I'm studying in CSC AIML, that is Computer Science and Engineering, with a specification of Artificial Intelligence and Machine Learning. My roll number is 24951A6602. I'm in third semester currently. In this tech talk of the subject of data structures, I'll be explaining about the topic key node separated graph clustering and layouts for human relationship graph visualization. Now let's go through the contents. First of all, I'll be giving an introduction to graphs, and after that I'll explain about modeling human relationship graphs, and after that we'll define key nodes precisely, and after that we'll be discussing about forming key node separated clusters, and after that we'll discuss about layouts that respect separation, and after that I'll explain about interaction and visual encoding, and after that we'll discuss about evaluation and metrics, and then we'll go through a case study which is about an organized network of 10,000 employees or 10 employees, and after that I'll explain about risks, ethics and governance, and after that finally I'll be concluding the topic. Now first of all, let's go through the introduction of this concept of graphs. A graph is a fundamental data structure in computer science and mathematics. A graph consists of a set of objects called vertices or nodes, whatever we call them, and connections between them called edges. This concept of graphs is used to model all kinds of real-world problems like social networks, transportation systems, communication links, etc. 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 Hence, this is the introduction to the concept of graphs. Now let's go through the modeling of human relationship graphs. The first aspect I'm going to discuss about is graphs and types of graphs. Types of graphs, by modeling them through human relationships, we can get three types of graphs. First is multiplex kind of graphs, which are further divided in work, family and online. And in the aspect of edges and directions, we have two types of graphs, undirected and directed. And in the aspect of edges and their weights, we have weighted and unweighted graphs. Hence, these are the types of graphs. Now let's go through the second aspect, vertices or people in real world, and edges, the relations between them. The attributes carried by people are five: role, the role of any person; team, or the combination of specific vertices; geography; seniority; and activity. The qualities carried by the relations between people are only two. First one is tie strength, second one is recency. Hence, these are the points I would like to state. Now the third aspect, data structures of those graphs. I would like to discuss about three major points. First, adjacency lists are used for sparse graphs. CESR or CSC is used for high performance analytics, and property graphs are used for attributes. Hence, this is the aspect of data structure. Now let's discuss about the fourth aspect, pre-processing. In pre-processing, there are four activities which occur. First is deduplication of identities. Second one is normalization of names. Third one is imputation of missing attributes. And the fourth one is filtration of weak or old ties in order to reduce the unwanted noise. Hence, this is the aspect of pre-processing. Now let's discuss about the fifth aspect, the final aspect of modeling human relationship graphs. Ethics baseline. Here, four things matter the most. The first one is consent of user. The second one is the access, the least privilege access. The third one is anonymization of the data. And the fourth one is to avoid sensitive inferences that could harm individuals, the users. Hence, this is the information about modeling human relationship graphs. Now let's discuss about defining key nodes precisely. The key nodes are majorly of five types. First one is centrality based. The four examples for it is degree or hubs, betweenness or bridges, eigenvector or page rank, which is also called as influence, and closeness or reachability. The second type is community based. Actually, midoids or centroids or highest scoring vertex are per community. Three major examples are Lovain, Leiden, Spectral. The third type is domain based. The anchors designated by business rules, out of which three are team leads, project owners, and experts. The fourth aspect is stability. We have to prefer robust metrics like the K-core or K-truth in order to avoid noisy key node selection on volatile graphs. And the final type is multi-criteria ranking. Normalized scores and weighted sum together combined can form a type, and type breaking through the recency or role priority can also be considered. Hence, these are the keynotes, types of keynotes which we can define precisely. Now let's talk about forming keynode separated clusters. Seed clusters from keynodes, they grow via BFS or expansion using similarity thresholds like edge weight, attribute match. An alternative for this is to run community detection first and select keynodes inside each detected community for anchoring. The three aspects I would like to state are as follows. First is constraint. We have to enforce minimum intercluster edge cuts for visual separation and merge tiny clusters into neighbors. Third one is overlaps. We have to handle multi-membership via soft clustering or fuzzy assignments or duplicating nodes as portals. The complexities for this expansion, that is O of V plus E, community methods near linear for sparse graphs, linear for sparse graphs, and the application of batching on streaming updates. Hence, this is the aspect of forming key node separated cluster. Now let's discuss about the layouts that respect separation. There are five major types of layouts. The first one is force directed layout. These force directed layouts have intuitive clusters due to which they have the capability to add intercluster repulsion parameters. Two of the examples are Facherman Reingold and Force Atlas 2. The second one is hierarchical or Sujiyama layout. These layouts are useful when edges have direction. Two of the examples are mentorship and reporting lines. The third one is radial or egocentric layout. They place key nodes on circles or satellites, whatever, which are arranged by tie strength or similarity. The fourth one is multi-level layout. They are also known as coarse layouts on cluster graphs. They refine inside clusters to reduce hairball at global scale. And the final one is aesthetic constraints. Minimal edge crossings, uniform edge lengths per cluster, label readability, and legend charity are considered as examples for aesthetic constraints. Hence, these are the layouts that respect separate. Now let's go through the interaction and visual encoding. Encodings are of four types: color by community or role encoding, size encoding by centrality, edge opacity by weight or recency type of encoding, and shape encoding for categories. And interactivities are of five types. First one is the combination of focus plus context or fish eye interactivity, search interactivity, hover tooltips interactivity, filter filtering by attribute and time, pin interactivity and unpin interactivity of keynodes. The edge bundling for intercluster ties on demand expansion of collapsed clusters to preserve readability, and legends and captions that explain keynote logic to avoid misinterpretation by non-experts, and the export views as snapshots for reporting, main provenance, which are timestamp parameters for auditability. Hence, this is the aspect of interaction and visual encoding. Now let's go through evaluation and metrics. There are five major aspects over here. First one is readability, which is further classified into three aspects: edge crossing count, cluster separation ratio, label overlap metrics, and structural fidelity. It is further classified into three aspects: modularity, conductance, and silhouette scores for community quality. And task performance, it is also further classified into three aspects: time to answer for analyst tasks, error rates, and user satisfaction surveys. And scalability is also further classified into three aspects: frame rate or interactive tools, layout time, memory footprint versus modulus of V and modulus of E. And stability is an aspect where layout variance across runs and incremental updates occur. We have to measure via progress distance. Hence, this is the aspect of evaluation. Now let's go through a case study, which is of an organized network of 10K employees. The data given is email co-communication plus project co-membership, weighted and time decayed edges. The keynote criteria is that 40% of betweenness plus 40% of page rank plus 20% of K core and one anchor per detected community. The pipeline. The community first results in representative selection, which further results in multi-level layout, which further results in interactive filtering, resulting in 35% of fewer edge crossings, and analysts located cross-team brokers 2x faster, and stable views occur week over week. And the caveats are only two: privacy review required and policy it forbids surfacing relationships with the interactions or monthly interactions which are lesser than n. Hence, this is the case study. Now let's go through the risks, ethics, and governance. The first point I would like to state that risk of reputational harm if visualization suggests undue influence occurs. Uncertainty is that it is to be communicated clearly. And we have a bias here that centrality can mirror structured inequities or accompany with diversity aware content. And the security in the security, identifiable data must be protected, role based access must be implemented, exports must be watermarked. And in the compliance, data retention limits, ability to purge edges on request, reproducible parameter logs a lot. Hence, human in the loop, we have to allow manual corrections in all kinds of errors to reflect domain ground truth. Hence, these are the risks, ethics, and governance. And now, finally, I would like to conclude the topic that hence, key node separated graph clustering helps simplify complex human relationship graphs and all kinds of related problems. It highlights important nodes or key individuals and organizes related groups around them. The layout techniques make large graphs easier to read and understood. In data structures, this approach shows how graphs can be organized, visualized, and interpreted efficiently, as we have already discussed. Now, I would like to sincerely thank the respected professors who gave me this wonderful opportunity to speak on about this topic.